का दुनिया में तू बेमिसाल मेरे बच्चे मेरे नाने हाल.
Hi, I am Newton. Before describing Newton's laws, I will tell you about force. Push or pull is called force. A force moves or tends to move. Stops or tends to stop motion of a body. Force can also change shape or direction of an object. Now next we will discuss inertia. The idea of inertia was introduced by Galileo. Let's talk to him about that. Hi everyone. I demolished the idea of Aristotle's falling body hypothesis that heavy objects fall faster than lighter objects. Through my experiments at Pisa Tower, I proved that heavy and light objects reached ground at the same time except for small effects of air resistance. Aristotle was wrong in another thing. He believed that rest is the natural state of object and push or pull is required to move an object. He thought vacuum could not exist and did not consider motion in absence of an interacting medium. I proved him wrong by conducting simple experiments. I took a slope and an object. I observed that a ball rolling on downward sloping picked up speed and ball rolling upward sloping planes lost speed. From this I reasoned that ball rolling down along a horizontal plane will neither speed up nor slow down. I also raised more questions on Aristotle's hypothesis by increasing and decreasing angle of inclination. As you see, a ball must attain the same height on an inclined plane if friction does not exist. If we decrease angle of incline, then ball covers more distance till it reach its initial height. Now what if the ball is thrown on a long horizontal plane? It will move forever till it reach its initial height in absence of friction. This property of motion to resist any change in motion is called inertia. My idea of inertia discredited the Aristotelian theory of motion. I opened the door for Newton to discover new horizons of universe. Consider a rocket in space at point A. Its engine is off and it is moving in deep space. It is not near any other planet or star. Its engine is fired for 2 seconds at point B. During this, rocket moves from point B to C. Its engine is again turned off at point C. Now guess in what direction the rocket will move. If you think the direction will be D or E, then you need to study my first law of motion. I refined Galileo's idea and presented my first law of motion in my book Principia. My first law is also called law of inertia. It states that a body continues its state of rest or uniform motion in a straight line provided no net force acts in it. A body at rest remains at rest is a well-known fact. A book placed on the table remains at rest because force exerted by earth on book is in downward direction, while force exerted by table on book is in upward direction. Since both forces cancels each other and net force is zero, hence the book will remain at rest. A ball moving with constant speed in a straight line stops after some time because of friction. If there is no friction, the ball will keep on moving. We will perform following activities for the first law of motion: fall of coin in a glass, tablecloth trick, and inertia hat. Let's do these activities practically. Now we are going to discuss second law of motion. My second law focuses on what happens when a net force acts on a body. When there is no net force, then body remains at rest or moves with constant velocity. But when net force acts on a body, it produces acceleration. Greater the net force, larger will be acceleration. Smaller the net force, then smaller the acceleration. So we can say acceleration is directly proportional to net force. Another factor that affects acceleration is mass. Higher the mass, lower the acceleration. Lower the mass, higher the acceleration. So we can say acceleration is inversely proportional to mass. Inversely means things change in opposite way. If one value is doubled, other is halved. So second law of motion states, the acceleration of an object is directly proportional to net force, in the direction of net force, and is inversely proportional to the mass of an object. Unit of force is Newton, which is equal to kilogram meter per second per second. A force is 1 Newton if it produces an acceleration of 1 meter per second in a mass of body 1 kg. Now we are going to discuss third law of motion. Every force is part of an interaction between one thing and another. When you push on a wall with your fingers, more is happening than you're pushing on the wall. There is a pair of forces involved, your push on the wall and the wall's push back on you. These forces are equal in magnitude and opposite in direction. In fact, you can't push on the wall unless the wall pushes back. Consider a boxer's fist hitting a massive punching bag. The fist hits the bag while the bag hits back on the fist. A pair of forces is involved in hitting the bag. The force pair can be quite large. But what of hitting a piece of tissue paper? The boxer's fist can only exert as much force on the tissue paper as the tissue paper can exert on the fist. Furthermore, the fist can't exert any force at all unless what is being hit exerts the same amount of force back. An interaction requires a pair of forces acting on two separate objects. So third law of motion states that to every action there is always an opposed equal reaction. It is also important to note that action and reaction do not cancel each other as they act on two different bodies. Moreover, same force does not mean same acceleration. Heavier objects have less acceleration as compared to small objects. Few more examples are shown in the slides.